This is a lesson in how to write chemical equations. Chemical equations might sound difficult, but essentially it's just recipes for chemical reactions. Now, in any recipe you need to know a few things. First of all, you need to know what your ingredients are. We call this the reactants. Next, it's helpful to know how much you need of everything. So all the numbers in chemical formula are simply there to tell us how much we need of different substances to make something new. Lastly, it helps to know what you're making. So the last part of the chemical equation is called the products, or what we've made from the reactants. This is a screenshot from our endothermic and exothermic lesson. And as you can see, we've got hydrogen gas and oxygen gas going to make water. Now, the very first thing we do when we think of chemical reactions is we get rid of the middle guy. All those atoms splitting apart there, we don't need to know about that. We just need to realize that they are going to split apart and they're going to become water molecules instead. The next thing we need to think about is energy released or is energy used up in this reaction? Well, look at the energy arrows going in and out. We've got a lot of energy being released when the hydrogens and the oxygens split apart, but not a lot of energy being used up to make the water molecules. So overall, we have more energy being released than used up. You also call that an exothermic reaction. Well, when we write this in a formula, whether it's what we call a word equation or a chemical formula equation, we just write the overall. So we don't worry about the in and out, we just say that overall we have energy being released in this reaction. Now notice how I've named everything here. I've written down hydrogen gas as a word, oxygen gas as a word, energy and water. We call this a word equation. So a word equation is essentially not even drawing the atoms themselves, just writing down the words or the names of what's there. Hydrogen gas, oxygen gas gives energy and makes water. That's your word equation. Now, to get a little bit more detail and to know what the actual molecules are made of, we write what we call the formula equation. Now, this is what that looks like. The hydrogen gas, first of all, we write down what the atoms look like. Sorry, the molecules look like. Because hydrogen molecules are made up of two hydrogen atoms joined together by a bond, as you can see above us. And oxygen molecules are two oxygen atoms joined together by bonds as well. So hydrogen gas is written as H2 and oxygen gas is O2. When they're written like that with the little numbers after it, that tells us that those atoms are joined together by a bond. Now the next thing I do is tell everyone that we've moved those towards making something new and that energy has been released using the arrows. And lastly, I write down our products. And our product here is H2O. Two hydrogen atoms joined together with one oxygen atom. Now that's all nice, and we call this a formula equation, but it doesn't tell me how much of everything was used in this. Now notice that we actually have two lots of H2 or hydrogen gas molecules. So to tell myself that I need two of them, I actually put a 2 in front of the hydrogen. Then look at the oxygen. I only have one lot of oxygen, so I put a 1 in front of the O2, or like in algebra, we don't even use the 1, we often just leave it out. If there's no number in front of it, that means that there's one of it. Lastly, there's two lots of water molecules there, so we put a 2 in front of the H2O. We call this a balanced formula equation. So to finish, we've got some notes that we need you to take down. First of all, chemical equations are recipes for chemical reactions. Just remember that one. Ways to write chemical equations. First is as a word one, where you put down the names in written form. So An example is hydrochloric acid and sodium hydroxide give sodium chloride and water. Now this is a common one that was in your experiments. This is where we have an acid and a base, and when you actually mix them, in this case it makes table salt and water. Now remember, on the left side you have your ingredients, which is also called the reactants, and on the right side we have our products, what we make. Everything is separated by a plus, and you have to have an arrow in between. Now the next way we write them is formula. Now this is important because chemical names can get quite big and it's annoying to have to write them over and over again. The formula tell you what atoms make up the molecules in a chemical reaction. This is very important. So in this case we have hydrochloric acid, which is HCl, plus sodium hydroxide, which is NaOH, gives sodium chloride, NaCl, plus water. Notice how the atoms are written with either big or big and little letters. So some of them, like hydrogen, are only written with one letter, whereas chlorine has a big letter and a little letter as its symbol. If you see a big letter and a little letter together, they are one symbol together. Lastly, if more than one molecule is needed in a reaction, then add the number in front. So for example, if you have 2 hydrochloric acids, you put a 2 in front of the HCl, which means 2 lots of HCl.